Yes, this time there are many types of memory ripples, and among them I will talk about full allocator. First of all, this full allocator is usually called a fix, also called pixel size locator. Actually, naming is up to each person at that time. Now, the basic meaning is that I'm going to use some memory pool, but I'm going to divide it into some fixed size. So as you can see in the picture here, the entire memory pool is allocated, and then you can cut it down to a certain size, and I'm going to use it. Then, for example, This is how we allocate 2000 bytes of sales. Then we divide each of these into backbytes, and we will use the memory space like this. Now, if you look at how some of these full-size allocators or fixed-size allocators behave, which you can see for a moment in this picture, let's first say that you've been allocated memory like this. And then this memory frame will have a starting address. For example, let's say we are young exilion. So let me say this memory default is 1000 bytes. So in this 1000 byte pool of memory, we can allocate a total of 10 pieces of data that are 100 bytes large. So this is it. 3, 6, 8, 9, 10 characters. So for each of these, if you divide this exactly by 10, there will definitely be starting addresses in each of these blocks of data. So what we see in this picture is that we put these in the form of a linked list. Each of these data start addresses. But in my case, although each person implements it in their own way, I put it in some queue. So, based on sepal code, the void pointer is generated like this. So at the very beginning, when we allocate any of these memory pools, as soon as we allocate them, we put the beginning of each data block, the addresses, in this queue. So for example, if I say I want to do eloc in this queue, do pop. So we're going to react, for example, to some of these initial surgeries. So we just have to call this creator here. On the other hand, if we say we want to do free now, let's say free in spirit, then we call the extinguisher again, constructor, then this structor, then back to this queue. Just give me a push. In this way, we can use fixed size locators. Now, we'll talk about this later, but the advantage of this fixed size allocator is that when we want to allocate memory in any memory pool, we can allocate and release it in 5 times a day. All you have to do is push and sell in this queue, so in terms of the speed of unallocation. It has the advantage of being fast, right? But what are the disadvantages? It's not flex. For example, we have now specified that we will unconditionally divide this memory pool into backbytes. Then we can't allocate data larger than 120, 200, 300. Memory leaf cannot be used for that purpose. Not 102, but across. In other words, we can assign 50, but if we say we're going to assign 100,000 to this 100 data block, this idea is not used. In other words, in this respect, there may be disadvantages in some memory utilization aspects.